Hello, can you hear me? I wish everybody to please mute yourself. Please mute yourself. Hey, Bharat, Zika, you people are requested to mute yourself. Zika, can you mute yourself? Bharat, please mute yourself. Please mute yourself.
False yesterday. This is a better option.
Mute yourself.
No, the time has come. I have cheating. It's
Could you please mute yourself, Megha? Megha, Prasanna, could you mute yourself, please?
Okay. ఇప్పుడే ప్రచారం ఇప్పుడు చెప్పా కదా 2 నిమిషాలకి బోర్డు తీసుకుందా క్యాన్సల్ చేసేది నేనే పంచుతారు ఎక్కడ కాదు మధ్యలో
అంతా పొడుపుడు ఒక అట్లే నడుస్తుంది నందిని ఇలా ఉంది అమ్మ ఇదేమి ఇట్లా సిక్తాలే ఎంత రేటు నేను జనరల్ అయిపోయింది
Megha, could you please mute yourself?
ಇರ್ತಾವೆ ಬೇರೆ ಕೊಡೋದು ಇಲ್ಲ ಸರಿ ಬೇಡವೋ ಒಂದಿಕ್ಕುವ
Megha, could you please mute yourself?
ಒಂದು ಚಾಕ್ಲೇಟ್ ಇಲ್ಲ
me? Okay. Start today's session. There are some technical issues because of that. Some friends were not muted, and that was creating a big trouble for everybody. So make sure you all are muted. Session. Before we again get into new things, let's quickly we did the other day. And if any question, we can discuss those questions quickly. We have to cover a lot in today's class. Is for only Manoj or for everybody? Okay, very much. In the last class, did basically went to understand for in uh, this testing. We understood ANOVA, understood chi-square test, and after that we understood correlation, how correlation is helpful, and finally we understood as a technique. In regression, we ran one regression model. We interpreted output. We understood what R square is. We understood why we run the t-tests. We also understood ANOVA in regression. Okay, we did very thoroughly. And we also understood by the end of the session what multicollinearity and you grapple with multicollinearity. So that's what we discussed the other day. And session we got into the discussion of machine learning. What is machine learning and the different forms of machine learning? I mean to say uh, what is swing and what is unsupervised learning. So we got into those kind of discussions. If you have any specific question, you can please ask me. And class, let me share a couple of some people asked me to discuss some topics. I generally don't take up like dummy creation of dummy variable and all because these things are very easy. But since you asked me, so uh, three files and import these three files. Let participant option. So you can and upload these files into environment very quickly. Okay, and we will continue our discussion from where we left the other day. So files, I given you one file of house case prices. I have added another variable into this, so you better use these three files. I'll be using these three files for today's discussion. Please download these three files and upload these files into your SAS environment. Done. Moment. Brenda is not done. What is the problem, Brenda, you are facing? Just a moment. I'll take the presenter access very quickly to help out. Screen so that I can help you. Yeah. What's the problem then? Okay. What problem you are facing then? Is- Okay. So please give me the presenter access back. Okay. So we were discussing about any other question? Good. In the meantime, I'm expecting you all to uh, upload all files into your SAS environment so that we don't lose a lot of time. So discussed about machine learning basically. In I tried to explain supervised and unsupervised learning. I like to give you some examples from the life scenarios, explain what supervised learning is and what is supervised learning. For that, I give you the example of human being that we try to club, when we try to bucketize anything, our previous experiences, previous examples, the supervised learning, but we are not looking for the past records, we are not looking for the past experiences, we are only looking for the pattern in the existing data That is called unsupervised learning. Supervised learning, I gave you the example, right? Supervised learning. In supervised learning, or pattern in the existing data. When pattern, this seems to be a very broad term. This seems to be a very vague term. Pattern, I mean to say, we look at some uh, parameter. Look at the pattern of some parameter. That pattern might be distance. That pattern might be some other statistical parameter. Those people who are into as well, they'll be learning assumption rules, market basket analysis, which is used in recommendation engines as well. Recommendation engines, I must have explained to you in the first class, what Amazon does to recommend you the products, what Netflix does to recommend you the movies. Okay, so how these recommendation engines work, that's also a part of unsupervised learning. Learning, example of fraud analytics. Okay, so in supervised learning, we'll be learning logistic regression. That will be the part of supervised learning. In unsupervised learning, we'll be learning cluster analysis. In today's class, what we do in cluster analysis. What is a cluster analysis? Learn what cluster analysis is all about. Then we'll be coming back to regression and then logistic regression and all. What do you want me to repeat? Supervised learning, we take the sense of the past data, past experiences, and then we categorize the present data. That is what we do in supervised learning. In supervised learning, we look at present data, whatever data we have at hand, and then we look at the pattern in the existing data. That we do in supervised and in unsupervised learning. Yes, is machine learning. Okay. Now let's come to cluster analysis. What is cluster analysis? Right. Yes. Right. Cluster analysis is an example of unsupervised learning. Supervised learning. I discussed this thing in the last session. Two examples for both. Have you visited what I did in the last class? Come to class before you read the last lecture. Okay, helpful for you as well as for the rest of the class. Cluster analysis, yes, we see some very good responses. It is about the segregation of data points by the characteristics. Uh, that group of same features. So let's discuss about it. What is a cluster analysis? Examples of cluster analysis, and that will serve for the examples of unsupervised learning as well. So Krishna, you again have a chance to get some good examples of unsupervised learning, because cluster analysis is unsupervised learning only. Okay, so you have another chance. So in marketing, is since I've always been into marketing strategy visions, so I've been doing the analytics for marketing strategies only. Marketing strategy can be uh, by three steps only. TP, T targeting, and then positioning. That is what you do in marketing strategies. For what you do, you recognize the segments in the market. Segments mean to say objects in such a way that in one segment you maximum homogeneity. So you have same kind of people. Segment you have objects who have similar kind of behavior, who have similar kind of preferences, who have similar kind of price. Okay? And different are heterogeneous. They are as heterogeneous as possible. Okay, difference between uh, different clusters. So segments are also termed as clusters in statistical terms. You have figured out, once you have recognized the segments, you those segments with the relevant products and the services. This is all about customization. Every customer wants to get a customized treatment. This is about that. Okay. So how we can customize our services, our product according to everybody's need. It will be very difficult for us. Positioning, very difficult for us to target each and every customer, because there are billions of your target customers. You will not be able to cater to each and everybody's need. So that is the reason you create the segments, so that you can cater to the needs of those segments in a way. You can go for the customization. This is all about marketing. The segments, and then you target those segments. Positioning is positioning is something which is related to the branding more. So about creating the image of your product, of your service in the mind of the customer. About share of mind and your share of heart in the customer. So I'll not be talking much about marketing, but the job is strategy. Got the answer, Brenda? So create the of your product, of your brand, or uh, in the mind of the customer. That's about positioning. Yes, the specific customers. Perfect. So positioning. So basically, this is about marketing strategy. Now let's talk about marketing campaigns. So tailoring your services and your products according to those segments. Suppose to run the campaigns, you need people with relevant advertisement, people with relevant emails, and that it will be consensical to reach people with the advertisement of those products and services which are not pertinent to that customer, that prospect. You would always like to reach your prospects, your customers with relevant advertisement, so that brand remained relevant in the mind of the customers, in the mind of the prospects. So, so you get a list of a million customers, a million prospects. You list into segments. You cater different segments accordingly. That is what you do in direct marketing campaigns of clustering analysis. In to again use clustering. I'll give an example in finance as well. So you want to diversify your investments across different companies and actually in some investment banking organization, it will be difficult for you to gauge each and every company. What you create clusters of the companies, their financial ratios, their market capitalization, their revenue, and all as a financial characteristics. And according to those financial characteristics, you can club different companies in clusters, and then you can decide about the investments into those clusters. That will be the way. Uh, clustering can be of many. I have explained to you in the first class that clustering can be hierarchical clustering, it can be k-mean clustering, and it can be DB scan clustering. Taking you through the algorithms of hierarchical clustering and k-mean clustering, DB scan clustering one step ahead, and I discuss DB scan clustering in my R classes used for segregation, for clustering the videos completely unstructured data. Okay, so let's start off our discussion with hierarchical clustering. How hierarchical clustering works. The thing's very easy for you. I have created this Excel which will help you to uh, grasp the concept of cluster analysis very well. Okay. Hierarchical clustering is concerned, we can use hierarchical clustering, but it's not very prevalent in the industry because the very reason of algorithm inherent with hierarchical clustering, time to get executed, and the output which is produced in the form of this diagram difficult to interpret if you have huge amount of data. Okay, this is a very preliminary way of creating the clusters which people used to go for when there used to be small amounts of data, but nowadays the amount of data has increased to such big levels. People usually don't go for hierarchical clustering. They k-mean clustering. Okay, but it's important to understand what happens inside the algorithm of hierarchical clustering as well, so that we have some idea of the inside process. We can have a feel of it. Okay, so far. Okay, to make the things easier, I have kept here only these observations, five records, I should say. These 5 records will try to create the clusters of these records. Okay. There are bills V1 and V2. For one, the value is 1 and V2 is 1. So if you want to plot it, you can plot it very easily on this plane, XY plane. This is uh, chord 1. Record 1. Uh, 2, 1. This is record 2. 4, comma 5. Record 3. This is for 7. This is 4. And this is record 5. We have plotted 5 records like this. These records on the argon plane, we'll try to the pattern. Now, what do we mean by pattern here? I told at the start that pattern is a very term. We need to understand the parameter at the pattern. So the parameter around which we look at the pattern is distance between data points. Algorithm, what clustering algorithm you are using, the point the between the data points. So what clustering algorithm tells you that between data points you how closely the behavior of those data points are related with each other. If they are closely situated, if the bit points is high, it simply means that the preferences, the priorities, the behavior of those two data points are likely to be very similar. So proximity lies in their behavior. High proximity implies high similarity between the 2 points. So 2 data points are very closely set in the argon plane. Clustering algorithm simply tells that these 2 data points have very high paucity of similar behavior. So if the proximity between these 2 data points is high, they will exhibit similar kind of behavior. This is what is suggesting your clustering algorithm. Let's use this particular bottom line and then try to understand how clusters are created. Each step in hierarchical clustering, we get this kind of matrix. You would see that's lying on the rows, same data points are lying on columns as well. So 3, 4, 5 in the column, 2, 3, 5 in the rows. And find out the distance between data points. So 0 is representing the distance between 1 and 1. This is representing the distance between 2 and 1. This is representing the distance between 3 and 1. This is the distance between 4 and 1. This will find out the distance between all pairs. Or we will see the same kind of values because the distance between 2 and 1 will be same as the distance between 1 and 2. So point fill these values as well. Finding out these distance values between all pairs, we look at that distance the minimum. The distance values will calculate, and after that we will the minimum distance value 1.0, if you would see, this is minimum distance value. The minimum distance value, what we do, we club those two data points together into one cluster. So the distance between 1 and 2 is found to be minimum. So what we'll do in the next step, we merge 1 and 2 into cluster A. Wait, one cluster A will call that, and 2 and 1. Now that uh, will place that 1 and 2 will be replaced now by cluster A. So these will be clubbed together in the next step, and this will be called as cluster A. I have cluster A 3, 4, and 5. Cluster 4 and 5. Again, you will find out the distance between data points. Now you know the distance between A and 3, A and 4, A and 5. Okay, this find out. I look at the minimum distance. 4 and between 4 and 3 is minimum. That is 2. Together into a cluster. That cluster B. And then we'll find out the distance between different data points. Process will keep going on and on until we get the optimal number of clusters. Now, take up the questions here because I don't want to move to where it will be difficult for me to come back. Any question? Please. You are right. Arrive at the distance in the above matrix. So we Euclidean distance methodology to arrive at the distance values. Distance methodology is you must have learned this in mathematics long time back. Let me quickly tell you what Euclidean distance methodology is. Just a moment, my system got hanged. I'm not able to cell. Yeah. So what we do in Euclidean distance, not very much required, but since we have, let me help you with that. Just a minute. Let me open another. Just a moment. Just give some. Tool. numbers x1, y1, two data points x1, y1, x2, y2. In these two would be the square root of x2 plus 1 y2 square. All things are done automatically, so you need not to worry about this. That's who calculated these distance values. I have some more questions. Mm. How can we find the distance between cluster A and 3 and 4? Okay, I come to that. How do I? So Prasanna, you got the answer to your question. I did not understand for scatter plot representation. Optimal means okay. Questions now. Just cell is restarting. Yeah. Okay. As how we calculated distances is plot. You was not able to understand the scatter plot. So it is only telling you the distances, how these two are related, how these two are placed. So I am these are in the first step. This one and this is two. 1 and 2 are clubbed together into cluster A. Between 1 and 2 was the minimum. What that was equal to 1. The 4 and 5 were clubbed together. Comma 5, comma 7. So the distance between these two are clubbed together. The next step. Razika, friend. We missed 7, comma 7 and 5, comma 7. Where did I miss that? 7, comma 7. Correct. 7, comma 7 is your data point 4. 5, comma 7 is your data point 5. Okay, come to the third step. People were asking about how I calculated the distance between A and 3, and 4, A and 5. Okay, so to calculate this distance, we again have methodologies. Okay, can go for single linkage, we can go for complete linkage, we can go for linkage, LQ. These all things are done by the tool only. So in this diagram, in one, linkage has been explained. Clusters. The distance between these two clusters can be calculated by finding out the distance between which are at the lowest distance. This of finding out the distance between the cluster is called as cell linkage method of out the distance between two clusters. In complete linkage method, what we do, we find out the distance between the objects which are at distance from the than in complete linkage methodology. In a linkage methodology, we find out the distance data points. We find out all the pairs. Okay, we find out the distance between all the pairs, and then finally average out the average linkage. The fourth is centroid linkage. And we find out the centroid of both the clusters, and then we find out the distance between centroid. That there are four methodologies to find out the distance between two clusters. So I used one of the methodology called linkage method to compute the distance between two clusters. I'll take up optimized clusters mean. Which cluster I mean to say, uh, in hierarchical clustering, it will start from all the data points and finally it converges to one single cluster. It is up to you to decide how clusters you want to create. So you with that, see, you can create here 3 clusters and you can create here 2 clusters as well. It is again up to you. It is your requirement as well. I will suppose you want to create some different types of scents for the example biscuits. So are an FMCG company and product. So packages you create for different types of people, to their preferences, according to their buying behavior, according to their purpose. So for us, you want to make a packet very size, okay? Because you research that they have the habit of buy biscuits on daily basis, so you would create a smaller for rural areas, and you would make uh, for areas and get for urban areas. Again, students, you might like to create small package. So basically, you do different segments, and according to those segments, you want to create the packages. And you also have your limitations, your business constraints. So suppose you have a plan to create 3 types of packages. Obviously, you would like to see 3 types of sets. So you already have in your mind that you want to create 3 clusters. So this is what I mean to say optimized number of clusters. Any question? Okay, good. So we understood what we do in hierarchical clustering. After doing hierarchical clustering, you get this kind of tree diagram. This is again produced by the two only. It is called as dendrogram. Very preliminary way because it takes a lot of time. The algorithm it uses it goes for multiple iterations. You see here, multiple iterations are done when we get to the optimized number of clusters. So generally, we don't use it. We have huge amount of data. The type which we mostly go for is called k-mean clustering. Some of you might have heard about this name as well. Okay, so understand the methodology and the algorithm which goes behind k-mean clustering. In k-clustering, what we do to the number of iterations, since we have understanding of the number of clusters which we want to create. So already no number of clusters here in case of clustering. So what do suppose we need to create two clusters here? But we randomly assign uh, different number. Okay, see what we have done here. That will explain you the everything. So 5 data points are again plotted in this way. What we have done, we have out the centroid of cluster A. In A we have taken B2, B3 and B4. B3 and B4. These 2, 3, we have clubbed into one cluster, and these two we have into another cluster that we have done randomly. Okay, three to one cluster and two have been clubbed into other cluster. We found out the centroid of these two clusters, cluster A and cluster B. Okay, randomly assigned the clusters here to different data points. For these 3 data points, we have assigned cluster A. For these 2 data points, we have assigned cluster B. So random seeding, this is called. So we take 2 seeds here. So randomly we have created 2 clusters here. We have done randomly. This what we go matrix. In which we find out the distance between each item cluster A. I mean to say the centroid of cluster A. Item 1, 1 and centroid A is calculated. The distance between item 2 and cluster A has been calculated. Item 3 and cluster A has been calculated. Item 4 and cluster A has been calculated. Item 5 and cluster A has been calculated. These distances again were calculated for B as well. Then we analyze. This for item 1. The distance of item 1 with cluster 1, the distance 1 with cluster A is 1.89. Distance of item 1 with cluster B is 7.81. This is surprising for me. Surprising for me because so this is 1. is item 1. So this distance is saying that the distance between D1 this 2 is D1 and this 2. If 1 belongs to cluster 1, the distance of 1, the center of cluster A, and distance of 1 from centroid of cluster B. So this is for me who could not understand this point. So last point I mentioned that the distance, ideally, if we have assigned the clusters in this way, the distance between I1 and the of cluster A is then the between 1 and the centroid of cluster B, because 1 belongs to cluster A. So bit 1 of cluster A should be least. It should its distance from any centroid, which is here. So no problem here. As well, this is existing here. But item 3, if you look at, this is item 3. What this distance is telling you that this distance D1, let's call it 3, 3, and let's 4 or D3 dash. Distance of 3 from the center of A. That of 3 with A. Its distance from cluster B. This is which because we have assigned cluster A to item. This step, item will be for B. Item 1, 2 would be cluster A, and the distances after recomputation of the centroids, and this will keep iterating. Okay, that's enough. That is what has been done. 3 and move to cluster B. Any question? How the reclustering gets repeated? Yesterday, I want each cluster to have least differences within their. You are right. Perfect. Perfectly put. How the reclustering? So between go over multiple iterations that you can see in the output, and that has nothing to do. K-mean clustering is a very fast procedure, and because of that, we use fast clusters to cancel and get the clusters. So you are telling the number of iterations. SAS will do everything on its own. It is very much automated. I understand how it happens behind the screens. Yes, and you will, if you are doing it manually, you will require to recompute the centroids, and the distance between each item centroids will be calculated, and the same procedure will uh, repeat it. Haven't you seen the difference between the two? The clustering, you go for finding out the minimum distance, and then you put the clusters together. So the algorithm is completely different between the two types. In hierarchical clustering, you use a different algorithm. In K-mean clustering, you use a different algorithm. This is something you have seen. Second difference is in hierarchical clustering, you can choose the number of clusters. It will suggest you the number of clusters as well in between, which not there in K-mean clustering. Is more practical. You always have the understanding of the number of clusters you want to create. Okay. So before clustering, you need to have the understanding of the number of clusters you want to create. Third, clustering is processing of K-mean clustering is very fast. So all these told you. In process, we merge the importance. Hierarchical clustering does not work very well when you have huge amount of data sets. So use hierarchical clustering. Uh, Krishna. Yes, here if you have here you have only questions. So you have 1 million observations. What will you with the hierarchical clustering? You will recognize anything. Yes, less than 50, uh, maybe more as well if you don't have any option. But we have some awesome techniques. Why would I go for hierarchical then? So we always came in clustering. We generally used K clustering only. Let's go and apply SAS. Please import set very quickly. Okay. Import pharma data. Just a moment. And comma. Leave it in work of. So I written the code this time so that we don't waste a lot of time. Let's give it a name pharma. You would this address only. I will reiterate. How can you find this address? In this file, go to properties and copy this address. And this here data file option. Instead of this, you can put address. Done. Yeah, Soumya, I'll send you. So the that document which you created and shared with everybody last time. That's something very. I'm wondering if Soumya can uh, create of document within the class. Why can't everybody? So this thing awesome. One part, and the most appreciable thing is that you shared with everybody for everyone's help. Shit. Okay, so you people must have imported the file so far. This file, if you look at, there are some companies mentioned here, and their symbols and here. Symbols are also called as ticks, tickets. I want to import pharma data. Pharmaceutical companies and their financial is given here. Tickets, people who are experts in finance. Yeah, when you have a company in the stock exchange, get yeah, then you are right. You get uh, one ID for your company that is ticker. I'm put these names intentionally so that if you get those things, you don't find it strange. Thanks, Ranjan. So when we import this data, uh, uh, let's all understand what we want to do with this data. So basically, we want to create the clusters of these companies according to parameters. It might not be. You need not to search for these companies in New York Stock Exchange or BSE or NSE, but just uh, I wanted you to know about this. So capitalization, beta, P ratio, ROA, SN over leverage, revenue growth, net profit margin. Okay, numeric variables you have in your data, and these numeric variables you want to variables, I should be calling them as financial parameters, financial ratios. According to those financial parameters, we want to create the clusters. We want to know the sort of companies. ONPE. So that's a different discussion. I don't want to get into financial discussions here, but good you're thinking in those terms. So yeah, that's good. Let's so we the sets around all the variables. Okay. But in go clustering, we need to look at something, the different numeric variables here are different uh, units as well. Here revenue growth percentage of, okay, structured, but you have different variables in ways. Okay, dollars, there are some percentages. Okay, about this situation here, you are looking at these financial parameters in marketing analytics, because I'm not a finance guy, to be very honest. Use some financial parameters. I work for a financial institute. Uh, my cat have not been into finance. They have been into statistics, uh, into marketing. And marketing background I have. Okay, Brenda. So we'll look at any marketing data as well. So you need to create the clusters of different people into their demographics. To hear Brenda. So talking about marketing analytics, and if you want to, yeah, analytics, you can precisely call it as, create the clusters, the clusters of different prospects according to their demographics. Demographic parameters, you would see age value, you would see the salary, okay, their uh, domicile, you would see parameters very different from each other. So be in years, some would be in dollars. Go about dealing with different types of variables, because here the example which I gave you earlier, this example, I these two variables are of same unit. But if they're not of same unit, how will I go about that? Ultimately, you are finding out the distance between the variables with data points. So, calculate the distance points. Yeah, you are all right. We need to all the variables into the common unit. Okay. To make them into a common unit, what we do, we standardize these variables. Some people term it as scaling the variables. Some people term it as normalizing the variables. Different people use different kind of terminologies, but ultimately, what they do, they subtract. What they do, they subtract each every number data points of the variable by its mean. Let me mean you at deviation in every point. This is called as Z view. Help. Can you tell me? Z is a distance, but how would we be able to get rid of that issue of its unit of each variable now? Bharat, you are right. Now, all is unitless. Suppose in market capitalization value minus the average of market capitalization, it's dollar only. Is again be in dollars. Ratio would be units. Okay. So basically, all bills would become, and that will help us in finding out the distance between the joints and then put into different clusters. Brenda, the unit of standard deviation, the unit of this will be dollars. What then? For Z will, okay. this is basically a proportion, uh, a unit thing. But you go about that. Let's do that. So we'll standard here. We can use standard because that will require the variables. We can learn here another procedural step, proc contents. About your data set, with information about the variables and all. Mention the data. Data is equal to P comma and see what it gets you. See, it gives you type, engine, created, last modified, blah blah blah. Too many things it gives you. Get the list variables you have, the type, length, format, in format, minutes it gives you. Okay. I'll add one thing here to make to from to the variables. We get short here. It will give you all the variables spaces, which is thing required to mention the name of the variable. Since we have many, that's why I used this. But I will have the code written here to make the things faster for you. Not to go for things. So the numeric variables I have kept here. And paste code so that you can also run. This code as well in the chat box. Standard deviation, you want mean as 0, standard deviation as 1, and out saved in standardized. Mention all the variables. Have been standardized. Standardized variables. Now you can go for class algorithm, fast class. So in proc fast class, Anything else? Yeah, please this one. In here, the standardized data. Suppose I want to create 4. It will subjective understanding and give you the cluster profiling. So far, anybody? Who all are? Okay, done. Yeah, that I paste here another code and then cluster. I believe I wrote this code again. Brent, we are facing. Can I help you? The data. Please codes to make it faster. Codes. So let's have in the output input. If you would see a new variable has been created. Another variable is distance which has been created. So this variable cluster is actually telling you the of record 1 belongs to cluster 2, record 2 belongs to cluster 1, record 3 belongs to cluster 3, record 4 belongs to cluster 2. So now have been created, distributed, all the points are clubbed together in this way. Any data set before into the results? these two last columns once will run plus. You can use these codes as it is. What is the name of the file which is saved in mylib? At the point error. Okay. Let's just quickly and please share quickly so that we can sort it out. Can we double click on farmer so that I look at it? Farmer. Great. Program. Paste the code here which you can use. Please the chat box. And go to, you have here, select everything, press 3, good. The last bit, I paste the code in the chat box, copy and in your code window and run it. Give. Okay. Let's understand the output. Are you Anyway, so let us output uh, the seed and then seed of summary, then shifts the variables. You should be interested in is bit cluster means and cluster standard deviation. To get into algorithm again, we have understood the whole algorithm. Let's look at the cluster means and cluster standard deviation, because the majority of the time goes into cluster profiling. Once you create the cluster, you need to find your cluster, what your cluster is containing. Okay. So let's look at market cap for cluster one. The mean market cap and standard deviation. So we find the clusters according to the values and the standard deviation. That one has a market cap of this, deviation of this. Here you can see these values are coming out to be negative because it is still considering Z statistic values. Statistic values you can convert back to the original values because you already have the information about the mean and the standard deviation. Okay. So you can convert these values back, that big deal, and then profile clusters. Cluster 3, it is give blank values above or invalid for correlated variables. So cluster summary here, there are observations you have in cluster 1, 2 observations in cluster 2, 1 observation in cluster 3, and 7 observations in cluster 4. That you are getting these standard deviations blank values. So basically, you have to perform two steps. In the first step, you analyze the data, and in the second step, you need to run this clustering algorithm. That is what you need to do. The final step is very important. You profile your clusters. You create the cluster profiles. You what your clusters are all about, and it actually comes into active understanding into your. I'll give you the example. You will, if you initial understanding, if you know the financial parameters, know the financial ratios, you can easily find out what cluster 1 is containing, what type of companies cluster A has. Okay. Let me give you the example which you may be able to relate better. At the last moment, I picked up this data. Uh, I'll give you some other data sets as well, and in your project as well, there are some other data sets as well which might be very close to your understanding, like marketing data you might get. In marketing data, you can see the clusters, and you can add the cluster profile like this. The age, you will look at the average age of this cluster, this segment, you can as a segment as well, is 25 years. Most of these people belong to rural area, so you can see what type of areas are there. Uh, their income is like this, and the standard deviation of the income is like this. Am I not well? Yeah. So you can infer out of this. More time goes into cluster profiling. There will be a lot of time we will go into outment. You would require to take out the outliers, compute the values for missing values. So that will also consume a lot of time. Okay. So that was about the cluster analysis, which I wanted to discuss here. Of analysis in clustering technique will be done in our classes as well. That so there are many which are to be taught, but they are left for our classes. So we have divided the course in this way. The next step is your data using R. The output data in which the object given the below of different clusters. So you can see the observation 1, record 1 is to cluster 2. Okay, 2, record 2 has been assigned to cluster 1. Okay. Any variable is of categorical nature. Niranjan, let me tell you, there are some tools which will pick up the categorical variables as it is, but many tools which might not pick. So I talk in terms of many tools. In SAS as well, you might need to convert those categories into new values. So you can use if then else statement and convert those categorical variables, those categories into numeric values. Then it will be able to help you. Dummy variables here in clustering. Am I So three categories. You give some numeric values. If the variable, suppose x to a, then 1. So the variable, yes, yes, back to the original values, become 1, 2, and 3, you can convert back into the original values as well. And values 1 and 2, 1, 2, and 3 as well. You know that what uh, these real values can have. Okay. Tell you what I do in these type of scenarios. Clear my experience here. So this is something which I'll tell you. Uh, uh, for your cluster analysis so that tool can find out what I do if I have a categorical variable. Suppose two categorical variables I have. What I do. Suppose you have different departments. Okay. Well, I'll set assets for different departments. So I'll do by by finding out the data points for different events, for different uh, regions, for different relations. But you will be able to figure out. Am I making sense? Keeping I have not used. I have DB scan clustering though, but immediate clustering I have not used. Uh, uh, in our course, yes, it is DB scan. DB scan. Up, Brenda, back to you. Uh, Let me pick up this question, then I'll come back to you. Between variables in each row, we give them as clusters. It is just around based on the distance between each row records for variables. We group them into clusters. You're getting that? So we group different rows. Okay. In the Brenda, the last two matrices in which try to define different standards for market cap is this value of mean and this value of standard deviation. No standard deviation because he has only one record. 3 has only one record. Only one record has been assigned to cluster 3. And then you do your cluster. Algorithm should tell me how many clusters are formed in the data. Uh, as well, you can go for multiple iterations. Like here, cluster 3 has only one data point. Creating 4 clusters, maybe you can go for 3 clusters only. Looking at the result, it would also show you what use you are putting into one cluster. You can pick up one sample. So it's a very iterative process. And let me tell you, clustering is something you see only mean and standard deviation is considered here. Otherwise, it is all about pattern recognition. Pure play data mining. Look at result and then again will come back to the code. You change number of clusters you want to create. So again forth. So in four, I would here to decide about the number of clusters. So here only one member was there in cluster 3. So instead of 4, I have now changed it to 3. So it is up to you. You go back and forth and see what you are getting. Then you just environment how many clusters you want to see. I have suppose created 3 packages. A triple C sudo f stat. No, no, no. In k clustering, these will not tell you. Yes, in hierarchical clustering, you can count the number of clusters for sure. In clustering, this is the prerequisite. It is a prerequisite that you should know the number of clusters. Yeah, with of hierarchical clustering, clusters. In the basic algorithm here is that you already know the number of clusters, and according to that, you create the initial seeds. Since and get the number of clusters. Yes, algorithm we discussed it at length, but coming back to you, but clustering, you decide number of clusters because then here what is happening. Okay. Problem with hierarchical clustering is it is very slow. So what you can do, uh, a random sample you can create a very small sample and then maybe you can try out that sample and see how many clusters are being created from that. Otherwise, hierarchical clustering would take huge of time. And how will you be able to figure out the number of clusters? You would look at this dendrogram for profiling, but uh, again, difficult for you to figure out. And actually, you have to use your business only. You have to use your business requirement only. If you have created four types of packages, you would look at four clusters from your dataset. If you have 1 million, how clumsy this dendrogram will become. Okay. Again, click a clustering only. This is something which you from hierarchical clustering, and from hierarchical clustering, you are finding out the number of clusters. Yeah, but that told you that hierarchical clustering is which is very time consuming. So can say that, but practically uh, you read number of clusters and then you use k-mean. Okay. And Neera was asking no, it was Chaitanya. The rule if clusters are more, profiling will be good. No, this is very active. Profiling is something very subjective. So since you get very weird clusters as well, then you get different values of those or different variables, that's or not. So you go for different treatments, but it is very subjective. So of that you go back and forth. Okay. It is able to show how the cluster profiling is done. Present customers. One cluster I can share my experience with you. I have 2 minutes for the break. So I used cluster analysis to most effective marketing channel. So the project was about effective marketing channels. Discuss this thing with you. So basically, be exists a unique relation. What it by using random marketing channels. Marketing channels and very randomly or user feelings. Actually cause a lot of spends and you get a very little budget, very small budget. So even 1%. Those people who are into finance and who understand how the budgets are allocated to different uh, departments, the market budget is 1%, 1.5%, not more than that. It is very small. And a budget, uh, you just afford to spend frivolously. So, according to different opportunities, so we have prospects, then deals. Okay, okay, gap, other other financial ratios of the company. Okay, so we are looking for in out as well as outside in parameters, and this is something you always need to consider. Only for I'm considering till now opportunity different other parameters for the I found out the cluster different size. So the industries we had. So explaining to Niranjan, I had different industries. So for industry, I run different algorithm to be very simple. So financial services industry, suppose I create districts. In year one, I found that the average deal size is around 10 million dollars. That looking at, they are falling in these companies. Some market cap. Okay, okay. The location. Suppose the location is US. This is something which I got cluster profiling for cluster. So it can be defined in this way that it has the prospects, the opportunities of around 10 million. You can range, you can find out the minimum value, maximum value, those kind of things you can do since you have the data with you. Okay. The most are of mid-size. These all companies are located in US. This is cluster one, and, and for these companies, you should go for these channels. You should go for thing which done in that project. Are you aware of it, Chaitanya? As far as profiling is concerned, you can really look at data now. sigma, you can find out, say, proc means equal to mean minimum maximum. Okay, where and then use we have proc means. Yeah, means what you can do, can clusters, you already know merge as well, so you can merge it with the original data and then you can play around. Okay, so here giving you by default the mean and standard deviation. You can also get to some other statistical parameters, descriptive statistical parameters if you want, using proc means. So then 10 million, that is other events, etc. Yes, so it is considerably less than 10 million. So I another clusters as well. Clusters were defined. Getting so clusters were defined, and if any new opportunity is coming, we will match that new opportunity with the existing clusters, and we will about the type of marketing channel we would be using. So we had the types of clusters from our data. Any new opportunity coming up, we match that new opportunity with the existing cluster, and then we will decide the marketing channel. Uh, it's a mid mark. Let's break minutes. We'll come back and learn something wonderful. A very interesting technique called logistic regression. Okay. And after logistic regression, uh, up with we were left in regression, linear regression as well. Okay. So 10 minutes break and come back quickly. Just a moment. Chetan discussed. Now you have all clusters within your file. So it's not about only a conversion of z score to the original values. You can have the mean value, you have the standard deviation, you know formula that z is equal to x minus mu by sigma. You can easily convert it back to the original values, but you need not to do that. You can merge these clusters the original data. Then you can count. So let's break here for 10 minutes and come back. from everybody who all are back. Thank you. So now we are going to learn something very important. It is one of the techniques of supervised learning as well as logistic regression. Understanding of regression, or we have some very good understanding of regression is done. Okay, now let's come to logistic regression and see logistic regression helps us with. So regression basically helps you when oh, oh, oh. Just a moment. Freeze. Just regression basically is used when we have a variable. When we have a dependent variable of by nature. Give you this example of a fraud analytics. Fraud analytics, I gave you this example that uh, occurs either into fraud or into fraud, a defaulter versus non-defaulter. So you may have two types of values. You can keep for default 0 and key for non-defaulter. Until has working. Let me close my Excel completely. Yeah. So only two types of values for response variable. One, yeah, so nature of dependent variable. I mean to say the Dependent variable can assume only two values. It can have one or it can have zero, one or two. Okay, two values it can assume. Say data set, uh, just I believe. If you will import that data set, let me help you import that. Let's use the same code so that we don't have to struggle with the coding part at least. Base codes, change the address. Please trust before you run. So this code, sorry, this file, it. Good. Okay. Done. Can we start the discussion? Okay. File have a variable called default. This variable is the dependent variable here. Have value 0 or 1. Others are duration, amount, installment, residence, age, number of cards. Okay. Okay. Of variables you have here. In a particular scenario, finding out uh, the regression model, say only one variable to make the regression easier. Say age as a variable. So I am here an independent variable, and variable I am giving 1 or 0. So age you will see for other age you will see 1. There are some zeros, there are some ones. We will be able to find a straight line. Straight line in this particular scenario doesn't make sense. We need to divide something else. Is a continuous variable we have here a dichotomous variable which can have either 1 or 0 as its value. Okay. Okay. Am I making this? Brendan, this? That in this particular scenario, when you have the dichotomous variable, when you have variable, it is impossible to find out a line. Yeah, it can have only two values. So find out a line is something nonsense. Find out a line, what we do in this particular scenario, out the probability value. To uh, the relationship between these variables. So I'm only taking up age right now. Let's call it A. I am plotting. It's called as sigmoid curve. Okay, a curve can be represented in this way: P is equal to e power by the power a. So value of probability value lies between 1 and 0. So it's 1 and it can't be less than 0 as well. So if you look at values, if a will goes to 0 and a will be a big number, what will be the probability? Okay, so these kinds. Manipulation into this. Age will age here. So equal to e divided by 1 plus a. Let's divide the denominator by power a. It will be 1 divided by 1 plus power minus a. Okay, so multiply. So 1 plus e raised to the power minus a multiplied e equal to 1. I'm trying of a. So 1 divided by p 1 equal to e to the power a. Take log minus a on b 1 p also called as ln net log by 1 minus p. So we equation here. I'll tell you why I am calling it as wonderful. But if you have any questions so far, anything. So he one variable. We considered only one variable. So multiple variables. So in A, what we do, we can replace A by a linear combination of those variables. A can be replaced by beta. This is what we did in linear regression as well. Beta 2 x2 equal to ln p by 1 minus p. Equation is called as low equation. Equation is called as Lorentz equation, and the term which is within this ln called as odds. So we have here in logic equation, we have log of odds equal to the combination of these variables. Okay, fx2, fx3. Let's write them it like this: beta naught plus beta 1 x plus beta 2 x2 obtain this equation. It's pretty excited. That said, a one equation. So tell me why I call it a equation. Why there is so special about it? how many problem question here? The definition is pretty straightforward. So derivation, because this definition will help you to understand and interpret the output. Otherwise, the output of the logistic regression model will be difficult for you to interpret. And you are right. So you need to connect the dots here. We started off our discussion with this issue that when we have only binary values for the response variable, when we have the dichotomous dependent variable, it is for us to relationship between the deep independent variable. Now can easily done using this equation, because here of odds have been related to linear combination of variables. Yes, Niranjan, you are right. Which will allow you to run regression model very in the same way we ran linear regression model. Okay, get into modeling and interpretation of the outputs. It's important for us to understand what is odds. What do you mean by odds? Understand what do we mean by odds? Who have stumbled, who have visited Los Angeles or the places where we have casinos and all, they will be aware about this term, odds ratio and all. What are odds? X to x3 are different independent variables, Krishna. Related to the likelihood, it is related to the chance. Let me be very explicit what odds ratio is. I have already defined it in front of you. So it's the simply the probability of occurrence divided by probability of non-occurrence. So occurrence by probability of non-occurrence. Might be very, might not. So it is occurrence. It is equal to probability of occurrence, probability of non-occurrence. Very simple. A couple of examples to quickly understand this. So I want to find out the odds. What is the probabilities? No involved in this, in that. So odds. Suppose find out the odds for head. Or we found out the probability of occurrence, means probability of head. If we are my head or it be tail, so 1 divided by 2 of head of occurrence. What probability of non-occurrence? It would be 1 by 2 of do this as well, 1:1. Okay. It's the ratio of only probabilities, not log. Okay. Log of odds, right? Like 8 income. Any okay. Just quickly for me, find out the odds just for or one or two uh, faced dice. So thing is which is six. One, three, four, five, six, six faces you have on that dice. It is unbiased. One or for one or two. But I don't want to. We don't want to waste much time here. You're looking for one or two. So one D, one minus one by three. One three. I have to say 0.3. Okay. 0.66. Okay. 1/2. No, Ranjan. Yeah. So it will 0.5. You are right. Okay. Ratio is the ratio of two odds. That's it. We would see these kind of terminologies. So odd ratio is odds. That's it. So actually tell you the comparison of occurrence and non-occurrence. Okay. So if you take the ratio of probability of occurrence to non-occurrence, it gives you 0.5. So point is not about 50% chance. The chance can will again be defined with the help of probability only. So chance is 1/3. It is the chance versus non-chances portion. Okay. Uh, 0.5 odds in head. This is term it as. Or also term it in this way. There is 1 to 2 in heads. So in as well, uh, if you people betting for different countries in footballs or in uh, cricket, you see these kind of terminologies. So in favor of India, win match is 1-2. This is go about it. So in as well, so you should actually understand it in this way: the ratio something happening to happening, something happening to something not happening. In the numerator, have the favorable condition, the probability of the favorable condition, and in the denominator, every but condition. So you don't have rest of the things. So in the case of head example, you call it as there is 1-to-1 chance in favor of get head in toss of a coin, in the toss of a fair coin. That is how you go about. Uh, to make it easier for you, you have one loaded coin, one fair coin. Okay, so the ratio will uh, help to understand it better. So let's first of all clarify all the doubts here at this point. Neeraj, am I making sense now? Only gives you difference between probability and odds. Uh, so you should take it in this way: probability gives you the proportion, and odds also gives you the proportion. Both the terms, both the statistical parameters, the probability, the ratio favor of outcome divided by the total number of outcome. Okay. In odds, you would see the rate between favorable and unfavorable. For this, uh, if you find out the probability of 1 or 0, 1 or 2, this be number of favorable outcome divided by the total number of outcome, 2 by 6 or 1 by 3. So 1 is the number of favorable outcome, 3 is the total number of outcome. Find out odds instead of probability. It's 1 divided by 2 is obviously 1 divided by 1 by 3. So these will be common, but in these numbers, it is giving you favorable number of outcome divided by unfavorable number of outcome. It's not about the total outcome. So we are giving you ratios, but in you are getting the ratio of favorable number of outcome to unfavorable number of outcome. But probability, you are getting the ratio of favorable number of outcome to the total outcome. Total will contain favorable as well as unfavorable. That thing, if you understand it that way. not both have the same question? It is being used of the reason of getting a portion, getting the comparison of versus another. Probability always talks about one. Uh, it out both. So if you are pairing two teams, okay, if you the ratio of one team versus another. So not talk about one thing. So here in case of probability, you see it talked about the other aspect, other side of the coin. It one set, and it pairing with the universe. So are going for um, gamma and all. These technologies are mostly used. You have to divide the probabilities and then get this number. So it's better off in this way that it is directly giving you the comparison of what you want and what you don't want. It is ratio directly. The second thing here, this mathematical formula comes out in such a way the it is taking up the law of odds. So interpret the output of logistic regression model. It's very important for us to understand what odds mean and how to apply the odds. Okay, odds no default. Default don't default is six. How would you interpret? Okay, I come to this. We have to discuss at length. What I want to let you know here about the basic algorithm, what we use here in logistic regression. Uh, in linear regression, we least square methodology. In case of logistic regression, we use maximum likelihood approach. Maximum likelihood approach we use to find out different coefficients, how we go out that it is about to come. Likelihood function we find out, and then we maximize that likelihood function to find out the cost of different variables. Okay, so let me quickly run the static regression model and take you through the output. Okay. So now let's do the details of what we have gotten as an output. One. So you use model statement on the left hand side. You keep the dependent variable of frequency. You make all the independent variables you have. When you run this, you will get this result. So and one by one each and everything. Getting into these kind of things. Uh, Ranjan's question before I get into these things, or default versus non-default is coming out to be suppose zero point 0.6. Repeat that so or default versus default. You are saying default and not default. This is non-default, default common non-default, or uh, common non-default. And you for people, each can be default or non-default. So this can be zero point 0.6 first of all. Okay, because considering here everything. Use for the table or non-default. So find everything here will suppose finding out odds for default. So uh, there are two events in sample space, and two A probability. You will see it is not equal. If the equal things would have been very easy for us, we would not gone for logistic regression. But suppose the probabilities are equal, they will be by 2 divided by 1 minus 1 by 2. You get so here you should consider only either default or non-default. Okay, so let's come to a result. What we have in this result, it is telling you a response variable. It is giving you a default number of response levels up to binary logic mode. Or here is a Fisher's scoring. Other tools like in Stata you have another operation technique which is I forgot that name. You can see it on Google. In they use a different thing, but if you get the same kind of result, observation profile, you have 700 observations with zero of default, and there are 300 observations default value as 1. Probability model is to 0. Here, whatever probability values will be calculated, that calculated for to, to 0. Something which is taken by default by SAS. If change it, want to get values for 1, you keep here descending in the first line. Get point? Place 0 here. In real scenarios, we most of the time give 1. So, suppose we are looking for the probability to default, we give default as 1. So the thing which we have the habit of doing. So instead of with the default value, we bet that we are very much used to of, which we are very much which is very much convenient for us, which is more conventional. So instead of using this, we can use descending option in the first line. Anybody question in this? Let me quote here. Oh, pasted. Please this one. So at the output now, is being changed. Now probability modeled is default is equal to 1. Probability modeled is default is equal to 1. We'll be getting the probabilities to 1. Probability fault basically will get. Any far? Okay. Come to the convergence is this all about. One conclusion from this stat says, one final conclusion from this stat 0, 1. So there are observations where value of default is 1, and there are 700 observations where the default value is 0. In your, if you look at, it is only telling you about a set. You look, default 0 means non-default. Yeah, fraud occurred. Yeah, or hit the print. Got it? this point. If you're sending, then we need to read 0 means default. No, no, no. Won't change the convention. So if you have kept 1 for default and non-default at the start, then after running the regression model, you'll not change. Yes, to use this option descending, then you can start at the outset only. You can it 0 is default and 1 instead of non-default. So there is descriptive. What by descriptive? No, no. What occurs is 0.7. No, no, no. You will not calculate the probability like that. Here, these things are not equally likely. You have parameters affecting this. Okay. I find default if there is new obs. Value default if there is a new obs. Our objective is to predict for the new customer. So you get a new customer and you want to predict the probability of his a default customer. You can out using logistic regression. That is you do in all supervised learning techniques. Okay. So data with us. Just a moment. Create a logistic regression model because we already know the values of default here. So get some other new customer, and customer, you know the age, you know the number of cards, residence, installment, and all, and you can then model to find out the probability to default. Bharat. So this data of the past records. These are past records. From these past records, you will build the model. You will create the function. Okay. For that function, you find the value of default the new customers. Is Bharat now? We will try to find out this model. This odds is equal to b0 plus beta 1 x1 plus beta 2 x2. Okay. and we will be able to find out these coefficients. We are done. We find out that probability as well. The probability is all about. So, it is ln by 1 minus p, and this uh, the x1, x2, x3. Okay. If you know the coefficients, you can find out the value of p as well. Let me show how p1 minus p would be equal to e power plus beta 1 plus beta 2 beta naught plus beta 1 x 2. Okay. And from the value of p, as we started with beta x1 2 divided with e power. If you know these coefficients beta naught, beta 1, beta 2, you find out the probability. So for customer, if a new customer is coming, you would know the value of x1, x2, and all. So you put here x1, x2, x3, x3. You know the coefficients beta naught, beta 1, beta 2. That will be the probability. Bharat, Krishna. And understand why I converted from to 1, and why I use that option descending, because I will have to convert it time and again. So I use this p. Let's model convergence status. Do much about this. This describes whether the maximum likelihood algorithm has converged or not, and tells you what kind of convergence criterion is used to uh, assess the convergence. So I have used relative gradient criterion, and this is 10 to the power minus 8, which is meeting here. So we need to worry about this. Next, we have model fit statistics. So here giving you two values for each criterion. For C, it is giving you two values. For SC, it is giving you two values, and for this to log L, it is giving you two values. Is for the intercept only. The second value is for intercept and covariates. It's very much like we have done in linear regression. A is an abbreviation which actually stands for Aiki Information Criterion. for IKEA information criterion. Write it for you. A A K E. Akai in criterion. Less the value of Akai information criterion would be the model. So intercept only it is showing you. It simply means that when you not considered the covariance, I mean to say the independent variables. So not considered the independent variables, a confirmation criteria is coming out to be 122.729. Consider the and covariates both when you have considered, when you have taken the variables into the account, the confirmation criteria has dropped down to 174.448. Okay. Let me tell you these about these three criterion. They have given all the three. Any one of these three would help the cause. A criteria, if you are taking this more than sufficient, then you need not to look for these two. Confirmation criteria as well as SC is derived from minus 2 likelihood. If you want mathematical formula, but that is not required. But uh, minus 2 log L minus log likelihood, both a confirmation criteria as well as L. It is difficult for me to pronounce its term Schwarz. You Schwarz, Cuarz. Schwarz criteria. So criterion it is gained find with the help of minus 2 log likelihood. So instead of looking for the 3, you can only look at this Akai information criteria only. If you add 2 to minus log likelihood, you will arrive at Akai information criteria only. This in the formula for next observation to determine fault or no fault. I can test after explanation of this. So first of all, let's look at these numbers, how to interpret these numbers. Okay, so I explained you what does AIC mean, what SC, and what you have as -2 log likelihood. Let's come to the interpretation part. Yes, Niranjan, I'm coming to that only. So talk about -2 log likelihood. -2 log likelihood is deviance. DEVIANCE. Okay, it is the null deviance, and then called as residual deviance. Null deviance is something which yet you don't have any variable involved. Variable. So it very much your mean when you involved any variable. So now you should remember that diagram in which I showed you the total deviation. So you have deviance, the total y minus y bar. Okay, Graham was able to explain some part of it, and some part of it was not being able to explain. So you see, deviation is 1221.729. When included the intercept as well as covariates, the deviation has come down. And to make it easier for you, you can compare it with SSE error. The unexplained part. So if you included the variables into your model, this SSC came down with something good model. It is something for your model. If you need to understand it better, you can compare it with, you can draw parallel, because you have already learned regression. You can draw parallel now. Instead of AIC, you can compare it with adjusted R square. V square, if we did the numerator as well as denominator by the corresponding degrees of freedom, the value of adjusted R square. AIC is also calculated by taking care of the degrees of freedom. By so degree of freedom, what does this mean? This means that you have taken the number of observations and you have taken the number of variables into account as well while calculation. So this serves the purpose of adjusted R square. Okay, both things have come down, so it simply means that this model is pretty good. SE, or say deviance, so how much is not explained by variables. Okay, Niranjan and everyone else. Next matrix will a lot to understand how good this model is. Let's come to the next matrix. This matrix is a global null hypothesis. Beta is equal to 0. Again, parallel. In ANOVA in regression was used to check the overall feasibility of the model. Same thing is done here. Okay. Here there's a test to check over feasibility of logistic regression model. It is coming out to be well in all three tests. Ratio something which we are interested in. Other tests also giving you the same information. Since you know about this SAS, it throws thing out, but you getting p values very significant from all the tests. So let me tell you what is the null hypothesis here. Which here the null hypothesis here is that without uh, the without uh, considering the independent variables and the deviance after considering the independent variables are different. They are same. You can negate by looking at these p values. Here are the numbers, but these p values would make the decision properly. There is a big difference between these deviance values, but this p value will help you to get that hypothesis as well. So the hypothesis is that this deviance and residual deviance both are same. They are significantly different. This is hypothesis. Now, hypothesis you can reject by looking at this p value. Please understand anything. I just don't want to rush the objects to make you understand. Model, yes. Global null hypothesis. So hypothesis is checking whether deviance is equal to deviance or not. So deviance, this is your residual deviance, which you are able to reject by looking at this p value. Yes. What about else? Is able to understand it? Others, please. Otherwise, it will be difficult for you to understand. In everything, the way we learned in regression, it's about 1,000 things, and knowing the things from each and everything. It's better to learn fewer things and good on those things so that our learning can be easier. So reject H naught, and you will say that the model is pretty much feasible. Question between dependent and independent variables? No, no. Just two log likelihood. I told you this is called as deviance. And parallel, consider it as error, squares of error, error sum square. It is decreasing here. Okay. Yes, yes. They are. What is that there is no significant difference, but you can see here there is a significant difference. The p value is coming out to be less than 0.05. Anybody before I move? So now telling me that I was fast. I have been fast. Difference is small. Would you test? So that is being tested by the null hypothesis. Some call it. Some people call it big one. It is one. Now some people will call one as a small. If you're working for a big company, a small company, they'll call 1 million as uh, uh, a big number. How will you get to a statement with a significant difference or not? Then you value, and that's why you are coming to the next block. What is only telling you that yes, D has dropped down. Dual deviance is less than nulls, but the second block is actually telling you, which you can interpret in a way that will help you to get a statement that yes, there is a significant difference between uh, and residual deviances. Your point, Niranjan? That's we are getting into the next block. What's any question? Because yeah, it was a relevant question. Thanks for asking. Okay, let's go to the next block. And maximum likelihood estimates. In multiple regression, that perform multiple t-tests to variables contour the model or not, whether coefficients are equal to 0 or not. You will be doing here as well. Okay, 0.0003 significant. But if you look at cars, it is not to be significant, coming out to be significant, and residence again is not coming out to be significant. Decide to get rid of these variables as well, or need to look at uh, uh, this variable, and you might need to take out the outliers, and you might need to, in the sample size, there may be different ways. But estimates are, that is something very important to understand. How will you make the equation with the help of this? That is something important to understand. Now, Brett, I would be able to answer your question. So, you were asking me about that equation, which me us to uh, the preview of it for any new customer. Good. So, pull these views here. So, write it like this. P by 1 minus P equal to B or not here? 1.68 0.0214 to age value into amount minus value into cards dot 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 dot. If equation and if new customer is coming up, can put here her age and can find out the value of P. Okay, so binary logic uh, these estimates the binary logic regression estimates for parameters in the model. Okay, you have seen it already that the logistic regression models the log odds for a positive response default is equal to 1 in this example as a mere combination of the predictor variables. Okay? So you interpret it these estimates. For one unit change in the predictor variable, the difference in the log odds for outcome is expected change by this value. Okay, variables are held constant. This is how to interpret these values. For change in the predictor variable, in log odds outcome is expected to change by if you are looking at age. Let me make the statement for age. For one unit change in age, this in log odds for a positive outcome is expected change by minus 0.0214. These are held constant. You got good. So let me tell you what odds really is all about. It is the this. So let me come to the next matrix. Now have all understood this? Anybody so far? 15 minutes left, but let's complete. Let's finish logistic regression today. It might, another minute or two. Let's with me. Uh, Anybody? Okay. Uh, for extension of what we have done in the last matrix. So it values when the estimate is exponentiated. So if you'll find out the value e raised to the power minus 0.0214, that will give you 979. However, this amount will give you 1. Okay, exponentiated values, because you get here the values around, you use logit regression model. The linear combination of different independent variable is equated to log of odds. Exponentiated values. I mean to say that this value is the power 0.0214 for the rest of them. And you are taking 95% confidence interval. Here getting the point estimates, it will give you the interval estimate. From this value to this value, from this value to this value, from this value to this value. So estimate is exponentiated, log odds ratio becomes odds ratio. So these are odds ratios. Interpret this one. Can anybody make an attempt? I you to interpret these values. Ratio you can interpret in this way. For 1 unit change in the predictor variable, so if you know about age, so for 1 unit change in age, the odds ratio for a positive outcome is expected to change by 0.979. Variables in the model are held constant. Positive outcome means default is equal to 1. To mention it every time that default is equal to 1. All these probabilities are calculated for default is equal to 1. You can call it as a favorable outcome. Understand the last bit. Percent concordance, percent discordant, and percent tied and pairs. Really, when you build the model, you look at that model from different perspectives. Model is good enough or not. So concordant and percentage also gives you whether it is good or not. To understand this, we need to Excel. I have created one Excel for you to make it better for you. I have to find that Excel because I had closed that. Let's start our discussion with the number of pairs. Number of pairs are 210,000. 10,000 pairs are there. So guess what this pair means? In the meantime, I'll find Excel. Let me tell you what these pairs are. So in the original data set, 300 options, 300 records, the default variable is 1, and there are 700 records where the value of default variable is 0. So this number 210,000 actually tells you of pairs. Actually tells you the number of pairs you can form from 1 and 0. Everybody with me? Numbers? Good. I've kept here this example from Google only, and I say it so that I can discuss it very fast. Otherwise, it's a lot of time to explain you in plain English. For uh, these are values of suppose default. Observed value of the variable default. So there's 1, 1, 1, 0, 0, 0. Okay. The observed values with the help of this model, you will get different probabilities against these values as well. After model, if you'll run the model on these values only, on set only, if you want to check how good your model is, you run the model on the existing data and you get some probabilities. Are your values predicted probability values? If you can try to draw that parallel with the multilinear regression. Oh, every time I do anything. Triple linear regression, if you remember, we had this point that was y, and we were getting one value of y. We had that was of independent variable x, and now you got this y hat you got by input of x into the model, created that model in terms of probability values. Just a moment. This model, you can get out the probability value for each record. Those values, these are at this point. Okay. Predicted probability values from the model, and these are the actual values, observed values. Without the total number of pairs. So you have where default value is 1, and there are 3 observations where the default values are 0. You will find out the number of pairs. Pairs would be 9. This is something you can find out by basic probability. This with this, with this, with this. Oh, my Excel has. Just give me a I this logistic requires a lot of time because people find it very confusing, difficult. They find it. Don't want to push through. One pair will this, another pair will be this. This way you will find out total. Okay, so let's talk about each pair and zero. Let's talk here. X1, the value. Get probability to get 1 is 0.91, and to get predicted value, the probability to get 1 here is 0.75. So concurrence. So I'm getting three blocks, three buckets here. I keep in concordant pair where the probability one in and probability of 1 in 0. So probability 1 is more than probability of 1 in 0. So all are the probabilities to find 1. Values of probabilities are the values to get 1. So this I would put in concordance. This pair. This pair is 0.91 and 0.06. Here, probability of getting 1 is less than probability of getting 0. You get all these type of pairs in concordant. In discordant, you would the off pairs. In which your situation like this. Let's talk about there. Like this 0.72 and point. So is 1 and here value is 0. But if at this pair, getting 1 in 1, sorry, it is 75. 0.75 it is. Oh. So 1 is 0.72 and probability of getting 1 in 0 is 0.75. Of getting 1 in 1 is less than probability of getting 1 in 0. This is discordant. In arts, let's not talk about too technical. The 1, okay, the probability out to be 0.72. 1. Don't hear the prediction. 0. But the probability of getting 1 is a big number. It is 0.75. That we are putting this pair into discordant. How many of this point? To close your laptops and the session, this is a very important concept which I'm trying my best to make you understand. How many of you with me? Okay. One. Just a moment. Why concordant? So you're talking about 0.91 and 0.5. Which you're talking about? 1 and 0.75, if you look at this 0.91, 0.75. Probability is high, but it's relatively lesser than putting it into concurrent. To help you understand it better, whenever you look at this probability 0.75, compare it with the benchmark of 0.5, which is not correct. When in this pair, this value is high. Undoubtedly, it is high if you are considering zero point 0.5 as a benchmark. 0.5, you those values lesser, and above 0.5, find those values as higher. From perspective, there's a high value, but the value is anyways lesser than 0.91. That's why you are putting it into concordant. We define concordant and discordant. Then you uh, bucket pairs into concordant, and you have the same number. If it is the same, then you put that into bucket. So here I have a tie. There is as well, and you can find out the percentages. So there are total of 9 pairs. Out of 9 pairs, 1, 2, 3, 4, 6, 6 pairs are concordant. So 6 points divided by 9 into 100. Then the percentage concordant in will be the percentage discordant. 1 divided by 9 would be 8 pairs. How many of you are not able to understand? Please let me know. Let's explain you. About Thank you. Okay, so I'll quickly tell you what test and train data sets are. Divide our data into two parts: test and train. Why that? I'll quickly, whenever we create any model, we want that model. So as that model, we first of all take up this issue in my pro discussion class, but let me quickly tell you what and why, or we can discuss it in tomorrow's class as well. Or let me give it 1 minute and quickly explain it. So if you have a data set, to data set here, we have here say 100 we can do. We can keep 70 observations. We can keep 70 records in trained data set, build our model on trained data set. Our model on 70% of the data. Model our model on the test data set, because we already know the answers, we already know the variable. So we can do, we can find out the probability values and then compare with actual values, so that find out how good our model is. It helps you to minimize the risk of overfitting. So it actually helps you. Any question in this, or any question from whatever we have learned so far? Have you? I believe you were asking about this. Have you understood? So statistic regression as well. Retail analysis. That is something which will not be taken care of in these classes. I've taken care of many case studies. So case studies are for your practice. We moved could have easily used those data sets instead of this. So something is done in your test set. That is what I explained to you. The model, you have one validation data set that is also called as test data set. Is one set which is called as a train data set. You build a model on data set and then you compare that model on data set. Okay. So I concepts now. What you do, you can divide data set into two parts. One part 50%, another part is 30%. Create a model on 70% of the data and apply that model on rest of the data. Case stat and rock. So there are many other things. As I mentioned, regression is a 6 month course. There are few things which are very important, which will help you to explore further. That is those things I have discussed here. So you can apply this formula on the test data set, and then you can check what all values are matching, what all values are not matching, how values are matching. This is a percentage, and then you can disable to that. Formula, yes. And then you can apply that formula. About my next hour SAS batches, you can get this confirmation, this information from Get Certified team. Can bring in our course. It will be discussed in much more detail, but I everything has been covered. There are many other things in regression. Regression, as I mentioned, it's a canvas. So not everything can be covered in classes or in our classes. There will be a few things which you need to explore. Okay. Okay. So, keep it till only, and let's meet tomorrow. I'll do everything before you come to the class tomorrow. We would be discussing time series modeling and some part of macros also left. See you tomorrow. And participate in the survey. Close the lid of your laptop. Please try to think over it, but this is I'm anyway covering in R, but in this version you have this proc tree. It's very complicated. In that we always go for SAS Enterprise Minor. I SAS Enterprise Minor for the decision tree. We would not be covering decision trees. That will be definitely covered in a greater detail using two packages, art and uh, party package classes. Okay. Thank you.